Hello there, welcome to the June 2019 paper 1. Here we're looking at question 2. Show that the integral from infinity to 0 of this expression here is equal to ln k, where k is a rational number to be found. Now in this question here, just looking at the integral, I can see here that this is going to be a partial fractions integral. So it's going to be 8x minus 12 over 2x squared plus 3x plus 1. And this is going to equal, now on the first fraction it's going to be 2x squared plus 3. Now on the top of the fraction here is going to be every power of x less than x squared. So it's ax plus b. And then it's going to be plus c over x plus 1. On this one here, the rule works as well. It's going to be every power less than x to the power of 1, and that's just c. So on the top should occur every power of x, starting from the top going right down to the constant that's less than the power on the bottom. Let's now multiply by the both brackets, so it'll be 8x minus 12 equals ax plus b bracket x plus 1. And then it's going to be plus c lots of 2x squared plus 3. Okay, let's just expand the brackets on the right hand side. It's going to give us ax squared plus bx plus ax plus b plus 2cx squared plus 3c. So let's now just group all the different parts together. X squared is going to have an a and plus 2c. The x component is going to be a plus b times x, and then the constant term is going to be 3c plus b. So what we can now do is compare this with 8x minus 12 that's on the left hand side. So if I first compare the x squared coefficient, well there is no x squared on the left hand side, so it's 0 on the left, and on the right it's going to be a plus 2c. With the x coefficient it's going to be 8 on the left hand side, and on the right hand side it's going to be a plus b. And with the minus 12, just the coefficient, just the constant term, minus 12 is going to equal 3c plus b. Okay, so this now needs solving. What I could do here is I could say that a is equal to minus 2c, and then I can substitute that into this expression here. So that's going to be 8 equals b minus 2c. Okay, so now that I've got that, what I could do is rearrange this one into b equals 2c plus 8, and then bring forward this one here, and that's going to be minus 12 equals 3c plus 2c, because I've got a b here, so it's 5c plus 8. So when I subtract my 8 onto the other side, I get minus 20 equals 5c. So therefore c equals minus 4. So let's go back and work out what b is now equal to. So 2 times c is minus 8, and then plus the 8 you get b is 0. And then a, you're going to get 8. Because minus 4 times minus 2 is positive 8. So therefore the integral that we're now going to be working out is the integral of ax, that would be 8x, over 2x squared plus 3, and then plus, so there'll be no b on the top there, and then it'll be plus c, which is equal to, and then it'll be minus 4 over x plus 1. Okay, let's just give ourselves a bit more space to work out that integral there. So it's going to be 8x over 2x squared plus 3 minus, what was it, minus 4 over x plus 1. And this is now going to be a integral, now it's from infinity to 0, so let's now deal with this bit here. Now there's not going to be any more values in between 0 to infinity that will make this integral an improper integral, so that's something to check as well. So what I'm going to do is introduce a limit of 0 on the bottom and t on the top, and then around this I'm going to put limit as t tends towards infinity. And I'll just carry on with that until I get to the final answer. So limit as t tends towards infinity of, now I think I'm ready to integrate now. On the first one, it's a Lund rule integration, whereby if you differentiate the bottom, you get 4x, but it's not quite the top, that's 8x, so it's just 2 multiples more than it, so it's 2 ln 2x squared plus 3 minus 4 ln x plus 1 in between the boundaries of t down to 0. So let's now substitute those in. T is tending towards infinity of, now substituting the first one, it's going to be 2 ln 2t squared plus 3 minus 4 ln t plus 1. That's t substituted in. Now we'll subtract 0 being substituted in. That's going to be 2 ln 3 minus 4 times ln 1. Ln 1 is just 0, so we can just ignore that last little bit. Okay, so the next thing to do will be probably to combine these two limits with t in them. So it's going to be ln of 2t squared plus 3 all to the power of 2 to incorporate the 2 inside this ln, and then we're going to divide that by t plus 1 to the power of 4. Okay, and then that's going to be minus 2 ln 3. We'll sort that out in a second. Okay, so this seems fine because as t gets bigger, the highest power on t is going to be 4. So actually, won't probably need to expand this. Just consider what will happen as t tends towards infinity. As t tends towards infinity, the fraction 2t squared plus 3, with the top bit being squared, over t plus 1 to the power of 4, what will happen to the highest power of t inside those top brackets there, top and bottom bracket? Well, on the top bracket, the coefficient of t to the power of 4 will be 4, and the coefficient of t to the power of 4 on this one will be 1, so it's going to tend towards 4 over 1, and these numbers here have come from the highest powers on the top and the bottom. The highest power of 4 on the top here is 4, the highest power on the highest coefficient of t to the power of 4 is 1, or the coefficient of t to the power of 4 is 1, so it's 4 over 1, so this will tend towards 4. So we've got that whole ln integral there tending towards 4 now, which is much more simple. So then this equals ln 4 minus 2 ln 3. Let's now incorporate that. Let's now incorporate this into one single logarithm. So it's going to be ln 8, 3 to the power, no, so 9 rather. 3 squared is 9, and then do the logarithms divided by each other. 4 divided by 9 is our answer. Woo! So k is equal to 4 over 9. Now hopefully this bit down the bottom here kind of made some sense. I'll just explain this a little bit more. What would we, if we were to expand this bracket here, we would get 4t to the power of 4 plus a whole bunch of other stuff down below. And if we expand the thing on the bottom, we would get t to the power of 4 plus a whole bunch of other stuff down the bottom. Now, as t gets very, very big, the other powers on t aren't going to get as big as t to the power of 4 will get big. Because it's being to the power of 4, it gets much bigger than any cubed expression, squared expression, etc., etc. So you're only really interested in the coefficients of t to the power of 4. So as this thing tends towards infinity, as t tends towards infinity, this thing here will tend towards 4 over 1. So that's why we get the expression of ln 4 coming out of this very complicated thing here, and then you can just simplify it to 4/9, incorporating the whole thing. So there we are, that's the answer for this question, question 2 here, worth 7 marks in total. Let's now move on to question 3.